Better.
Yep.
Yes.
Okay. Hey, this is Dave Bazuki. I'm founder and CEO at Roblox, and today you're listening to Tech Talks. Today we are diving into the future of communication, how we do it safely and authentically. And we've shared many times, we believe immersive 3D and 4D communication is part of the future of communication. So today, Rajiv Bhatia, welcome Raj. Raj is our head of product for user and discovery. Great to have you here, Raj.
Thanks.
Okay. Naren Konaru, what's up? Engineering,
great.
safety.
Yes.
Great to have you. And then
Thanks for
Eliza
having me.
Jacobs, head of policy at safety. A lot of people might not know what safety policy is, so we're going to dive into that as well. And I want to frame first just the magnitude of what we're going to be talking about today, because this is at RDC and at other conferences, we've shared our vision that when we start thinking about facial age estimation and age checks, just to set the stage for what we're going to be talking about today, can you just a quick heads up before we dive in on the engineering and ethical foundation of like how we're going to do this?
We've been working on AI for a very, very long time. And AI is obviously, we built this muscle over the last 4 or 5 years, and we've been playing around with a lot of these technologies. And we feel like at this point, the technology has become more accurate so that we could actually rely on the age estimation technology to reliably estimate people's ages for making decisions on the platform.
Which is a radical evolution, because I don't know if it was you or other people, 4 or 5 years ago, we were talking about primitive BERT filters, enhancing our text filtration, and we've come so far now.
That's right.
Being able to do this on a device.
Yeah, BERT was the first LLM that we used to launch our first version of the text filter. And now we are at a point where we can do this ephemeral age estimation so that we could do it in a very privacy-preserving way and still get the accuracy that we need to reliably estimate.
Okay, awesome. So we're going to dive in on the tech. We're going to dive in on privacy, all of that. Humans naturally want to storytell and communicate together. We've started with literally the mail system, the telegraph system, the phone system, the video system. In the midst of COVID, we found that more and more people were using Roblox to communicate. And so this is a really important topic. We're going to be talking today about how we do that both authentically and safely. Specifically, we're going to be diving into a little bit of the future of AI. We've been an AI company for 4 or 5 years behind the scenes, but we're going to be focusing on age estimation technology and what that means. So, let's just dive in a bit first and talk about what this means to frame it all. Raj, I don't know what are we talking about when we say age estimation?
Yeah, well, I'm very excited that we're here talking about innovation in communication safety. And we're launching 2 big things. The first one is what you just talked about, which is age estimation on the platform. We're making a pretty big change in the platform to require every user on the platform that wants to access communication to do an age check. And there's 2 ways that you can do an age check. We've got the traditional ID verification that people have been able to do for a long time on the platform, but we're now introducing facial age estimation, where you can just, using your device camera, you can conduct an age estimation right there in the convenience of your home without having to upload anything. It just takes a minute. It's really quick and it's highly accurate. And we're really excited about that.
Okay, so we're going to be diving into this technology. Naren, from an engineering standpoint, what can you share about this technology? Why has it become possible all of a sudden? A little background for our users.
AI is all about data, right? And we have had so much of this data in our systems, and using that, we can build like pretty sophisticated models with an average precision of within like 1 to 2 years. So I think it all comes down to, can we leverage the data to build accurate models, which I think is actually the simplest part, right? The hardest part is, how do you detect fraud? How do you detect that, okay, somebody's not just showing a picture or a video and tricking you into these systems? That is really hard. How do you detect that, okay, people are just putting makeup to, kind of avoid the age checks? That's hard.
I would think, can I put on a Mission Impossible mask?
Yeah, exactly. Right?
Okay, or can I put a picture up? So we're going to dive into a bit of that.
That's right.
Today as well.
Okay. Yeah, so I think fraud checks is the hardest part, and making sure that we can accurately predict the age is okay. It's not the most challenging, but I think the fraud is the hardest one. And then reliably making sure that it works across the scale that we have today, which is like about 150 million users come to our platform. And how do you make sure that these systems don't go down, we return within a minute. Those are all the hard engineering challenges that we work on.
Okay, so we're going to be talking about age estimation, civility, and safety. And then Eliza, we can all imagine product and engineering, but many of the listeners might not realize what a depth of policy we have going on. Could you share a little of the policy implications of age estimation?
Yeah, a couple of things. One, we were really thoughtful about what we felt was developmentally appropriate at different sort of ages and stages, and who should be talking to who. And then from a policy perspective, this is a space where for a long time there's just been no technological way to know the age of kids, right? Like that, they don't have IDs. There's no way to do this. So it's so exciting to marry the safety policy side of the house with the engineering side, and really do what we think is right for the community.
Okay, so I think this is one area that highlights from the start at Roblox. We made it known we believe there's 12 and unders on the platform, and we want to design and build for them. And when I think about this technology and where we are kind of in the current history of communication, a couple things about Roblox, right? We've gotten to where we are, about 150 million daily active users, with this very big vision of a platform where people optimistically play together and connect. We've done it arguably in a very fortunate way, in that we've come across an economic model that has allowed us to add more engineers, more AI developers, all of that, and build this amazing platform and have all of these creators on it. And so sometimes when I think about this issue, I think it's fair to say we do things before laws are written, right? California Age Appropriate Design Code, things like that. So there's kind of this combination of, we're in a fortunate position. We want to take the long view on this. We want to be very responsible about this. And really, what I would say is a big issue. Maybe going straight to the challenges of, why are we uniquely doing this? What are the challenges that we're looking at here?
We take that role that we have as the preeminent destination for people of all ages to come together on the platform and to play games together, to connect with each other, to learn. And we have a really wide range of ages on the platform. And two challenges that we see emerging when we think about communication on the platform is, one, do I have confidence in who that other person is on the other side? Do I have a assurance that that they're who they say they are, that they're the age they are? Self-reported age is just not good enough. And we're
Can
taking
you
the
say-
step to go.
Can you share for what the audience self-reported age is?
Yeah, a lot of pretty much every platform out there does this today. You sign up for an account, you enter a birthday based fully on what you want to enter, and that's called the self-reported age.
I love Google Docs, but
And civil experience. And the first part of that we need to solve is making sure that we have high confidence in everyone's
Yeah.
ages.
maybe looking at traditional age, techniques of either self-reported or other. Naren, what's insufficient about those things?
Yeah. Back to what Raj is saying, our platform can range, our users can range from 5-year-old to like 70-year-old people, right? So, and we cannot just rely on the self-declared age because we have the right set of defaults for different age groups, but we need to make sure that the age is actually correct.
And so I would
traditionally-
say, so some of the people out there are going to ask, well, what were you doing before then? And I think it's fair to say we had to design for the wide range of people,
Correct.
not necessarily saying in all cases the exact right age. And so I think maybe that just for background for the people out there, it's why we filter all the chat.
That's right.
Yep.
Right? And then we have ID verification to access some of the features on the platform. But how many 13-year-olds have IDs? Right. So that's
Yeah.
just not possible. And if you look at some of the other platforms, what they've been doing is to look at the behavioral signals to estimate an age.
That's
And
right.
while that can work in like coarse age groups, it's very hard to pin down the exact users of the people. And this is why we're excited about the facial age estimation, because that can bring you down within like 1 to 2 years range of your real age. And that changes everything for us.
So we're going to come back to that, but that's a really interesting tidbit, is the accuracy of AI age estimation, especially when coupled with other signals. Eliza, when we look at the risks, of both age estimation and other types of technology to estimate age, can you share a little from a policy standpoint?
We've always had a fully filtered platform. We don't allow image and video sharing. We're monitoring in the background for critical harm. So we've got models running in the background and sending to our internal investigations team if we see anything going on that we think might be unsafe. So this is just one of a layered approach to safety, because we always knew we had kids. So to go back to your question about self-reported age, we knew that wasn't a perfect signal, and we built systems based on knowing that. So it's super exciting to add this much more reliable signal to just bake into our safety systems.
This is a very new thing I want to highlight, and it's been very hard to get an age checker and age estimation on such a wide range of people that are handed devices. I will highlight, there's a lot of great minds out there. Everyone wants the right thing. There's discussion, should devices try to know the age of users? Should that be a law, for example? Like if I hand you a phone, I say 12-year-old kind of thing. I would say there's a thought on our part of not waiting for that. I also think there's arguably a robustness of, rather than just trusting that signal, the more signals, the better. So I think it's fair to say, both with our age estimation and our other signals, if the device had a signal as well, in a sense, we'd mathematically convolute that and put it together to get even a better signal.
100%. We are using the face-to-age estimation as to predict the age, but we use a lot of behavioral signals to see when you're kind of not behaving like yourself, right? Like what if you gave your phone to your older brother and have them age check for you?
Well, that almost gets into maybe diving into a little of how it works.
Yeah.
You're on the engineering side. And then I'm going to randomly ask you questions like I'm just listening to this for the first time.
Let's do that.
So how does it, first from a technical thing, and then we'll go from a user journey thing.
Yeah.
So first, technology, how does this work?
From a super simple thing, you just pull out your phone, say, start age verification, within a minute you're done. And it takes your selfie, which is what we actually use for the age estimation. But then there is liveness checks to prevent all the fraud. right? So we ask you to turn left and right, and that's kind of when we see, hey, is there any superimposition going on? Because the ears are really important, the makeup is really important, and we look at all of this to make sure that there's no fraud, and you're not just showing a picture or showing a video, AI generated video.
Okay, so what happens if I find my older brother and I push this up? Do I get that age then?
You will get that age in that moment.
Okay.
But then in the background, we are running our continuous age estimation based on your behavior on the platform, who you're talking to, what games you're playing, how you're typing, right? Your spelling. All of this can be indications of coarse-grained age buckets. And then when we detect that, okay, let's say you gave it to your older brother who's 5 years older, but then we detect that it's younger, we will re-challenge you. So you better get the same age brother again at that moment. Otherwise,
So my brother should just come with me all the time, basically. Okay.
That's right.
And then how about my really cool Mission Impossible 3D mannequin head? Like, can I put that up and rotate it?
Well, we tried. It didn't work.
Oh, really?
So, yeah.
You tried that?
Yeah. We have a team that is trying to break the system all the time.
Yeah.
Yes, we did try, and it doesn't work. Again, these are all the things that we've been developing and improving our models over time. It was very hard to break it.
A long time ago, there's these sci-fi adventures where people would go to a terminal somewhere and like log in and pay for something. And that was thought of as the preemptor to internet payment. And then in the early days of internet payment, everyone was very skeptical. Like, no one's really going to trust a credit card. How good's the encryption? Do we have, SSL or whatever, and all of that. And then now where we are, literally there's like 39 payment providers that like I breathe on my browser and it's just like choo, pay kind of thing. I do feel this is kind of where we are right now. It's a new thing. A lot of people are used to taking selfies and a lot of people are used to sharing images. So that camera is available. So I'm excited. Maybe Raj more on the user journey side of this.
So Naren described a little bit of the sort of steps a user would take. But when we first started thinking about adding this to the app, I was really worried that it was going to be a lot of friction.
Yeah.
I'm actually really surprised that it's not. It feels very natural. It feels very intuitive.
Do you remember the meeting we had where I think you handed out a lot of phones?
Yeah.
And very early on, we actually, I think it's also fair to say we preempted this discussion by testing and using age estimation earlier
internally,
in our life cycle. We got signal from that. We reviewed the signal both on PCs, Macs, Android, iOS devices.
Yep.
And can you share what it was like when you handed out those devices? Like everyone, I kind of knew in that moment, like this is gonna go forward.
Again, it was a lot smoother than people expected it to be.
Yeah.
And when you're a user and you're prompted to start your age check, it's a pretty seamless experience. Once you opt in to doing the age check, you give permission for our app to take to use your camera.
Yeah.
And as Naren described, basically it's doing live photo captures and it's just doing a liveness check. And within a minute, the system has estimated your age and given you feedback on what age we estimate you to be. And it's very easy if you disagree with that to click a button and say, I disagree with this. I have alternative proof, whether that's an ID that you want to upload or if you want to get your parents involved to correct your age.
And I think that's why we call it age check,
Yes.
in that we feel there's many signals and they'll get more and more comprehensive over time.
Yep. And then, of course, we haven't talked about this much, but once you go through that age check and you get that age estimation back, that then unlocks communication on the platform for you. And so once you have that, when you head into chat, you'll see that you're able to chat with others that are also age checked, and you'll have conversation with them.
Can you talk about policy around that and technology and whether, is there some risk everyone's photo is going to show up somewhere or something like that?
Yeah. So we call this ephemeral age estimation, right? So yes, we do get your image and video, selfie video, but then those images and videos are deleted right after the process is complete.
Right.
So even if you want it, we can't get it because they're deleted right away after the age
So for everyone out there, ephemeral means kind of like evaporating or disappearing.
It just disappears. So we don't have that data anymore.
Yeah.
We will collect the metadata, which is like the age of that person that we estimated. We will store that with the account, but the real images and videos, they're gone. They're nowhere to be found. Right?
So that's really a balance then between safety and privacy.
Yeah, we deeply care about the privacy for the users, right? So
okay, so then communicating how this is going to work. It's interesting, right? Because we're going to talk about how we would communicate this to parents and users around the world. Trick question would be, what's the best place to communicate?
Yeah,
where 150 million people come.
Yes, 150 million people a day are coming to our app.
And there's no way to communicate at any wider way than literally the app itself.
It is the best place for us to communicate this and try to make it as clear as possible. So we do rely on the app, the in-app education, the in-app user flows to communicate what's happening and provide any links you may have, provide any answers to questions you might have about it. So we try to make it as smooth and easy and straightforward as possible in the app. And I'm, again, very proud of the way we've integrated into the app. But if you have questions, we link out to the Safety Center. The Safety Center has a boatload of really great resources for parents and for users to understand.
Roblox.com/Safety Center.
Oh, even better.
Yep.
Yes.
Okay, Roblox.com Safety Center.
With regards to age checks and age-based chat, those two products that we're launching, we even have fun explainer videos that go through the functionality of both of those in about 30 seconds each on the platform.
Also, for people listening, maybe thinking about how age estimation, age check fits into the broader architecture, I think it's fair to say when we're talking about safety and civility, we're talking about something this big. And today we're talking about a new addition to something that's much broader, right? There's content safety, communication safety, filtering, all of those kind of things. Can you share a little how this plugs into that?
When we think about safety, you have to have defense in depth, and we have to approach it from many different angles. But beyond that, all the content that is uploaded to Roblox is proactively moderated. We rely on user reports. We understand, we can make mistakes. In this case, we rely on user reports to tell us when we make mistakes, and then we look at them, right? And all the communication is filtered by default. And our filters are different for different age groups, and that's there. And our communication is not encrypted, which means that we are monitoring this communication for critical harms all the time as well, right? We don't let images or videos to be shared within communication as well. So I think all of these controls make Roblox a really safe platform.
Yeah, the way I think about it is over time, as we continuously get better and better at our ability to estimate the age of everyone on the platform, it forms a foundation that everyone over time is going to know and expect. It's a little bit why we called it the gold standard in a way. There's something also that I feel this unlocks, and we can talk a little about it. The more we really estimate and know the age of everyone on the platform, we can start looking into minor and adult communication. And I would say in addition to chat filtering, and even with chat filtering, we can start taking a look at to what extent we should allow that.
Right now, as we launch this age estimation, we won't be allowing kids to talk to adults, so that will be cut off. Kids will only be able to talk to their peers. I think there are many use cases where kids talking to adults is totally appropriate, right? Like kids talk to their teachers and to their piano teachers and all those folks, their older brothers. And so we do need to build a system where that is allowed, where you're talking to trusted adults. And we will do that with our Trusted Connections product.
Yep.
I think the other thing to note is once we estimate your age, we're going to put you in all of the defaults for that age, not just about communication, but also for content maturity, right? What games can you play, for feature access and things like that. So we're really focused on a developmentally appropriate process of opening up features and access to content as kids grow up. And, I know, Naren, your kids are teenagers, so handing them a device and sort of trusting them is fine. But maybe for a 9-year-old, that's a different situation.
So I think when I was 6, I would probably have wanted access to the 18-year-old content, just knowing what I was like when I was 6. So I think we are already very careful with that as far as ID check and a bunch of other things, but this does allow us to supplement that in certain areas. And what's going to be interesting is I think that'll be part of the pull of age checking. Like I want to age check in a way to be part of whatever my appropriate community is.
Yeah, kids want to be in their peer groups and playing what their peers are playing, and I think this will help us do that and to allow them to age up on the platform as is appropriate as they grow up on Roblox.
Okay, so I'm a user. I don't know if users will hear this before or after the US rollout. We'll find out. But what should I expect?
The first thing I think people will feel once they age check and join chat with their peers, and I think they'll feel like they're in this group of people that are all age checked. That there's a level of validation that has occurred, and I think their confidence in who they're speaking with, and knowing that their peers will increase. And I think at first, I think it'll be interesting to see how fast people pick up on getting their age check done and then joining chat. At first, it might feel a little bit quieter, and that's okay, like maybe for the first few days. But I think very quickly after that, they'll start to see and feel communication that mirrors what they see in the real world. They'll be hanging out with people that are their similar age. They'll be having the same type of conversations that they have at school, on the playground, with their peer groups. And it'll start to feel, I think, really natural. And I think that's what we're going for, something that is, essentially age appropriate, natural, where you feel like you're in this trusted group together. And I think that's what people will see.
If we reflect that into the larger vision of Roblox, which is optimistically and safely bring people together, and this notion of building a platform for all ages, we did something, I think, aligned with our vision, in that if we were looking at the phone system in the 60s, or if we were looking at the video communication system, those typically are platforms that we can see having utility for younger people, for 13 and up people, for communication with grandparents and kids, with peers. With all of that, can you share a bit on the notion of age estimation and age check with this vision of a platform for all ages?
We don't want to hold back access, right? We do feel like everyone should be able to use the platform to communicate, to connect with their peers, to play games with their peers. We're not asking for a lot. We're asking you to check your age. And then we're going to put you into a developmentally appropriate and civil experience, and you'll have access to that. And as Eliza mentioned, if you want to go beyond that, if you want to play games with your older cousin that's in another state, or if you want to play games with your parents, Trusted Connections allows you to do that too. And that's very possible on the platform. So we want to support all those valid use cases while also balancing default safety for everybody on the platform.
Going back to responsibility then, and looking at the industry as a whole, we have about 150 million DAUs. There is a wide range of social networking apps, social communication apps, AI apps, gaming apps. Some are 13 up, some are all ages. And we are, I think, thinking about this industry-wide issue, both on age estimation and other things. Can you share a little about our industry collaboration and like how could we kind of get together and join up on some of this stuff?
Yeah, absolutely. So I think safety is in general a shared problem on the internet. It's not just us. I think every other platform also has the same problem as well, right? Or similar challenges. So I think we've been open sourcing a lot of our models, right? So anytime we think that we have a pretty sophisticated model that is world class and it is broadly applicable to a wider range of the industries, we try to give it away so that we raise the overall safety on the internet, right? So we did this with voice classifier about a couple of years ago. Earlier this year, we open sourced Sentinel, which is our real-time detection model for critical harms. We also open sourced our PII model just recently. And one day we probably will open source our age estimation model as well when we feel like it's really good and ready to be shared there. Now, on top of this, we also collaborate with this open source initiative called Roost. We've been founding members of that organization, and there the mission is to really build a wide variety of tools that are applicable across the industry and that can be shared across multiple partners. So we've been the founding members of there as well, and we collaborate very closely with them.
Okay, and that is, I would say, not just good for business, but good for the industry as a whole. And arguably over time, as we lean into these AI technologies, we should, by default, have more and more of the industry's leading AI models to help support this. Stepping out of the product side and the engineering side, from the policy side, I think Sometimes we talk about speaking without adjectives, just pure facts, like not marketing speak or comm speak, just like the raw facts of what we're doing here relative to the industry. Could you share your perspective on that?
Yeah, this launch is industry leading. Nobody else has launched age estimation at this kind of scale and to gate these kinds of features. It just isn't being done anywhere else, and we're so proud to be the first and be out ahead. But we really hope other companies follow, right? Because what we don't want to happen is, well, I don't want to age estimate there, so I'll just go use some other app.
That's right.
And so it only works if we all work together and do it responsibly. And so we're proud to be leaders, but we hope that we get some followers as well. And we're only seeing more of this kind of regulation going out globally, right? Like Australia just launched their 16 plus social media ban. So lots of platforms are having to retrofit this kinds of technology to be able to comply with those regulations. And we're just not going to have to do that. We're going to have already built it. We've already integrated it. We've done it in a way that's thoughtful to our community, that works for our users. And so we think that's a better way to do it. Take the long view, be out ahead of where we think the industry is going.
Yeah, and I do think we'll go through this new phase, but I think culturally and technically, we're just at the forefront of many other, similar innovations. I think back to all of the innovations we made in the company. There was a time when it seemed pretty radical to use AI to dynamically translate whatever a creator made into a bunch of languages. And we moved from that being a new phase to something it's just, of course, the platform has it. Any other final cultural projections of where this is going or what we're going to see when we look back in a year or two at this? My own impression is we're going to look back at this as just one more innovative stage of something that people assume all of these platforms include.
I think that's right. I think, there's a lot of things that have sort of led up to this, right? Like we're all used to unlocking our iPhone with our face. And I think that having been doing that for the last couple of years makes this feel like a more natural part of the future. I was on a plane yesterday and I went through security by having my face checked. So it's just going to be a more natural part of our lives. And as long as we're being really conscientious about the privacy components of that, I think, to your point about friction, right? It's just, it's an easier, faster way really for everyone than doing an ID verification to get the right information that we need to keep everyone safe.
All right.
I would quickly add, if we're able to make come true that concept that more and more platforms will join us in this move, I think we'll look back on this as, well, of course you want to be honest about who you are on the platform, on the internet. Of course you want to be clear about your age and you want other people to know and have confidence and you are representing who you really are on the platform. And I think this will hopefully be the start of that across the internet more broadly.
We are rolling out Australia, New Zealand. I think it's been a week or two. Yep. I think it's fair to say we're pleasantly surprised with that.
We're very surprised and very happy with the progress so far.
And arguably some pretty big numbers.
Yes.
Okay, awesome. So thank you, Raj. Thank you, Eliza. Thank you, Naren. This is one more as we roll out safety innovations across the platform. It's really exciting to dive in both, I would say, policy, technically, and product-wise. We'll be back with a lot more future innovations as we roll them out. So this is Dave Baszucki. This has been Tech Talks. Thanks again for joining us, and I'll look forward to seeing you next time. Thank you. Hey, welcome. This is Dave Baszucki, Roblox CEO, bringing you another Roblox Today update. Today's Thursday, January 8th, and we wanted to share some of the progress on our age check rollout. We're tracking on a similar curve in the US and the rest of the world on adoption, just as we saw in Australia and New Zealand when we did the rollout last month. I want to share a few things we have planned as part of the rollout. First, we're expanding how trusted connections enable communication with friends and family with either a phone contact or a QR code. Stay tuned on this. Second, we're going to be expanding the control creators have to help users match with other users of similar ages in game instances. And third, we're exploring a pathway for verified influencers to have conversations with their fans. Fourth, we're working on giving devs more visibility on chats in their experiences to better understand and moderate their experiences. Remember, age estimation is fast, it's simple, and we don't retain any images in the process. And you can also use the time. Hey, this is Dave Baszucki. I'm founder and CEO of Roblox, and you're listening or watching Tech Talks. So today we're going to be talking about what makes up a second generation game engine, how it involves cloud, how we help users join instantly at high resolution. We've got the technical dream team here as part of Roblox. So we've got Varun Meni, we've got Sergey Mikheyev, and Svetanov. And we're going to be diving into everything streaming. We're going to be talking about Slim. We're talking about asset transcoding. If we look at the gaming industry for the last 10 or 20 years, there's a traditional way that all this 3D content gets in front of you. And there's some issues with this traditional way, because what we're trying to do at Roblox, join instantly. We're trying to have the same experiences run on a phone as well as a giant PC. We're trying to do this without any latency. And when we look at the way traditional games work, it's not quite the same, right? Like I can remember in my days, they were distributed on these things called floppy disks. But even today, right, we distribute games on big DVDs, I think. Is that fair to say?
Yeah, and I think that the key to it is it's all packaged together,
Yeah.
right? So whether it's a DVD or whether it's you're downloading a game today, it's coming as one giant package that you cannot split it up. So you have to wait until the entire 4.7 gigs or 10 gigs in some cases fully downloads before you can start.
Yes, and as Varun said, like for some games that could be like 20, 40 gigs, and you have to wait like for a very long time before you can start playing. And that's kind of, like killing this like flow, right? So because like you want to play, you have like maybe like an hour or 2 hours like after work, you want to play a game and then you have to wait like for 30, 40 minutes like while it's updates. And like pretty much that's much like my experience like playing anything.
So isn't that it's somewhat akin to what we've seen in video and movies? I can remember a time when movies were distributed on DVDs. And then I could remember a time with BitTorrent, for example, you would download the whole thing. And then finally we got to like, I go to my Amazon or my Netflix or my Hulu or my Tubi and I can watch right now. But I don't think that's quite happened in the gaming market yet.
Not yet. I think
Not yet.
We are the only one that are targeting that.
So historically, Roblox has worked that way. And behind the scenes, most people might not notice it, but when you go to that homepage of Roblox and you click play, you can join instantly. This is actually very non-traditional because when I'm on some very elegant gaming platforms, I've gone as high as seeing 200 gigabytes of a download occur before I can play. So we're already doing this instant play.
Yes, Roblox, as far as I know, is the only platform that allows this instant join and play.
The kind of like when you were talking about the video streaming, right? Like what are you actually doing when you're doing a video stream where I don't want to download the entire movie. I'm just downloading just enough of the movie in front of me, and we call that buffering. I'm streaming the movie, right? That's just in one dimension because there's only a time dimension there. That's the key difference here. That's what's hard about doing it in Roblox because it's a fully interactive 3D world where you have to stream in both instances and assets, which is kind of the basic building blocks of everything in Roblox.
And I would say this is made even more difficult because in the traditional video game market, I tend to see different versions of games on like a high-end PC and low-end mobile. And the way I interpret that is on high-end PCs where I can like download hundreds of gigabytes, you're gonna have these really big complex assets. And on mobiles, it's almost like creators, I think, make a separate version.
Yes, so that's a very good point, because like in traditional games, like they have this process that's called like asset cooking. So they are preparing a very optimized version like of their assets like per platform. And if you think about it like from more like video streaming perspective, then like it's like on DVD. The video was just encoded once, right?
Yeah.
So, but like on any streaming platforms, they have like multiple encodings like for the same video. So it's kind of automatically fits your device. And all current games, they, like they pre-cook like their assets like and ship a very specific version of it. So while at Roblox here, so we are able to generate optimized version of an asset per platform.
That's right. So hold that thought, right? Because a while ago, we had the vision of if you're a young creator and you make your experience, it can run in any language. We had the vision that it can run on any device, and running at various resolutions on any device, we're gonna dive into it. So traditional gaming market, packaged, either downloaded. We want to solve those problems of instant access, published for any device, low latency, and all of that together. And so we're going to be talking today about is something called literally 3D and 4D streaming. We're going to be talking about contents in the cloud. We're going to be talking about something called Slim, which I think everyone's going to get really excited. And so maybe to dive in, Varun, first, a little vision on what is Slim and what we call cloud transcoding, and what's that all mean?
So if we take a step back, if you think about like our overall vision is we're trying to get to 10% of the gaming market.
Yeah.
The way we do that is to give creators complete freedom over what they build. And if you think about how we grow, there's kind of two dimensions. You could either do platform expansion, or we could do genre expansion. Platform expansion is how do we get the same content to work on any platform? So you create once, Roblox makes sure it works everywhere. And then genre expansions, we want you to create more and more impressive things and more crazy things out there.
And just so when you say run anywhere, literally, imagine something really big and crazy and fun, Grand Theft Auto, Red Dead Redemption, high-end console, running on 2 gigabyte Android
and
phone.
everything in between.
That's
right?
right.
So beefy PC all the way down to 2 gig Android should just work without the creator having to do extra work. So that's the vision.
Exactly.
Cloud transcoding and Slim are just two of the first steps we've started to take down that path.
Okay, so that's a bit of a teaser. We're going to explain what Slim is, and we're going to explain, I think you'll probably explain what transcoding is, but let's keep introing first, everyone. So Sergey, can you share a little of your background in engine optimization? One of the most fun things in the world, right? C++, assembly language, like SIMD. Can you share a bit of what you've been working on?
Yeah, I'm pretty much been working on games or game engines for my entire life. Doing those low level optimizations, starting from the original Xbox and stuff. And when I first learned about Roblox, my mind was just blown away with this idea of a game created just once. Or not a game, maybe any experience created just once, and then it's able to run everywhere on any platform, on any device, without requiring any additional user input. And that's an extremely challenging engineering problem, as everyone can imagine, right? So, and that's required a lot of traditional optimizations like SIMD, multi-threading, very careful, GPU scheduling, all of that. But at the same time, there some limit on how much we can scale on a single device. But fortunately for us, we always have our cloud, right? So, and we can offload some of this work to our cloud and help those devices to render more efficiently, to render bigger worlds. To a degree, when we can render some worlds that cannot even fit into a physical device memory, because they also exist on the server side, and server helps all the clients to render them efficiently.
Yeah, and so just as a highlight, I think part of the hint that we're going to be sharing underneath it is traditional game engines typically written C++, and you download all of the assets. But say a game you wanted to play was the entire world, for example. No one can put the entire world on a DVD. And so what you're really hinting at, and we see it already with Google Maps and other types of that. There's no way you can put all of that in the same place. And so part of what we're going to talk about when we say streaming is that same thing for games. And then Svetlana, can you kind of what got you to Roblox and what was your background and maybe a little bit of a hint of what cloud transcoding is?
So before joining Roblox, I spent my professional experience in two domains. One is 3D design and simulation software for architecture, construction, and mechanical engineering. And the second one was large-scale distributed computing, which I can apply my knowledge from both those domains into Roblox because pretty much that's what Roblox is.
Yep. Let's jump over to streaming on Roblox and talk about it. So we know what video streaming is. Video is kind of a linear thing, right? I just need a frame after a frame. We send one after the other. Can you share what streaming might mean in 3D in real time?
If you actually look at what almost everything in a Roblox game today is made up of instances or assets, right?
Yeah.
Instance is kind of the structure of the world, and then an asset is the thing that's actually driving that instance for the actual content. If you think about streaming, it's about streaming instances and streaming those assets as well that you have to do. So if in a video stream, you just have one asset, that's the video. In Roblox, we're doing that thousands, 10,000 times over and over and over. So when you're saying instant streaming, you're just trying to stream in enough of the world around you, and you don't know what the player is going to do. The player might walk this way, the player might walk that way. You want to stream just enough or buffer enough of the world. And then in that world that you've buffered, you want to buffer the assets at exactly the right quality. So as Sergey mentioned, you have different quality levels for video. We have the same thing for meshes, the same thing for images.
So if we broke it down, would it be fair to say the instances are things we might be familiar with, a car, a tree, another person, a hill, something like that. And then the assets are the technical things that make up those instances. Like inside of those 3D objects, when we're all on a game, we have like blobs of triangles, we have blobs of textures. And so we're talking about picking which of those to really pull in at any time.
Yeah, and which representation of them. So as you're walking through the world, it's like the device is saying, okay, I want that tree, or I need that tree. That tree is made up of a bunch of meshes and of a bunch of textures, and maybe even in the future, animations, audio, so on and so forth. So then it's deciding, okay, based off of the position of that tree, the importance of it, how much screen space it's taking, I want the texture at high quality, I want the mesh at medium quality, and then the audio, maybe I don't need the audio yet, so don't hold off on the audio. So it's constantly making those decisions.
So in a way, this is a little like when I use a mapping program, I bring in just the little images
chunk,
of the map. Yeah. We're talking the 3D versions of that and, interactive 3D components as well. Okay. And there's something really essential here. Behind the scenes, I would say our vision has always been, no matter what device or whatever you're on, we're trying to get the right ones in as quickly as possible. And sometimes we say we want to get them in as quickly as possible to maximize the human perception of magic. Like you're just, whoa, the world appeared for me. So Sergey, how do we pick and how do we sort what to load and what to bring in?
So yeah, optimization for perceived, latency, it's very important because as Varun just mentioned, we constantly measuring, screen space area, how important that object is, and for example, if you see a tree at a very close distance, or you see exactly the same tree at a very long distance, those could be two different trees, right? So if you see it from the distance, you don't really care about fine texture details or something. So we can always fetch low resolution texture for the tree. You won't be able to distinguish between if it's a low res or a high res texture because it's just very small on your screen. But on the other hand, we can fetch it almost immediately because there's way less data. But when you get closer to this tree, we'll progressively fetch more and more data, and it will look more detailed. So you won't be able to see the transition, you won't be able to tell the difference, but you will be immediately able to see and interact with that.
And part of this is when I'm using either my 2 gig Android phone or my gaming PC, and I want to join something instantly, even though the internet is really fast, we don't have infinite bandwidth. Like we're trying to push the world through that pipe, whether you've got 10 megabits a second or 100 megabits per second, and balance what we push through there. And one way I sometimes think about it is one tree that's close to me can use the same information as 100 trees that are far away from me. And essentially, the 100 trees that are far away from me may have the visual importance as the one that's close, and we bring them in at different resolution. Like the one that's close to me is much more high fidelity than the ones that are far away.
Yes, that's exactly right. And the important point that you also mentioned is we're not only measuring, how important that object is, but how much compute resource do we have, how much memory do we have, network bandwidth, everything. So we take into account everything that affect user experience, and that include performance, how much memory do we have, and all of that.
So we've talked about instances are like the tree, the assets are the mesh or the textures. Can you share more how they differ and what underneath the covers really we're doing with asset streaming?
Yes, for instance streaming, the server decides what is important.
Yep.
And based on the importance, it gives this information, pushes this information down to every client, and every client actually gets a different instances for that, depending is it visible, it's not visible, is it participating in the interactive part or not. For the asset streaming, it's the client that actually streams in what was in the world, based on the quality that we are targeting, as Sergey said, based on the capabilities of the device, we are only targeting those exact representations based on the quality and based on the capability of the device. Pretty much that's how we are.
So those trees way off in the distance hopefully are very compact, right? A lower resolution, not taking a lot of it, so we can spend more time and more compute with the tree that's closer into me. And so we have this thing called the content pipeline or that asset pipeline. Can you share a little about, if I'm a game creator, what does this transcoding pipeline look like? I'm using Roblox Studio, I build a really nice car. What happens behind the scenes?
Because of the improvements in engine, we also wanted to preserve the artistic intent for the designers and game developers. So we came up with this idea of cloud transcoding that allows us to ingest the content from the creators, store it, optimize it based on the devices and capabilities that the client needs. And this pipeline is end-to-end. It is lazy on-demand. What that means is that when the client requests a specific representation, only then, if we don't have that representation, we start a compute. If not, we return it if it already existed. So we are very optimal on the bandwidth and the compute that we are providing to the client.
So if there's a long time ago when we didn't have this, or maybe actually pretty recently, that we had to put limits on the fidelity of these assets. I think we would say you can only have so many triangles in your car, and the more triangles, the more accurate your car looks, or we'd say you can only have so many pixels in the size of a texture. What we're saying now is, I believe, you can upload that car however you've built it, and then when you say transcoding behind the scenes, we're making various versions of that car, really, with fewer and fewer triangles?
Yes, that is correct. Or up, actually, in the future.
Yeah.
And so we have this capability now that we can, depending on the improvements of the engine and compute power that we have, we can improve the representation of number of triangles or texture maps or audio, video, animation, whatever we need.
So this is on demand. And I think what you were saying earlier, Sergey, is you used to have something called baking, like you would bake the high end. We're essentially baking on demand many versions of that car at various resolutions. They're all sitting there, and then the car way off in the distance I may see is one of those lower resolution ones. And this is, I believe, what we're calling transcoding.
Yes.
So how does transcoding work? How do you take 1 million triangles and turn it into 1,000 triangles?
I mean, that ingestion. So to Studio, we actually ingest that 1 million triangle mesh. We then store it in our backend content platform backend system. And then upon request, we actually run LOD processing.
Which stands for level of detail.
Level of detail, which means depending on, we are trying to preserve as much quality for that limited representation of the mesh or texture.
So if maybe, Varun, if we thought about how this is working across devices, you're So Svetlana, you're the creator. You put in this giant high-res car. I'm on a low-end Android device. You're on a high-end PC gaming device. Hopefully we can still play the same game. Like
Exactly,
what
right.
happens for both of us?
And so basically when my client comes online, it's like, hey, I'm a low-end Android device. I want this specific, because one thing we didn't mention actually, it's not just about level of detail, but it's also a platform-specific representation. So Android, iOS, each of these different platforms have very specific representations that you can compress the textures. You can actually conform them in such a way that it works way more optimally. So my Android device will come online and say, hey, I want the Android version of a low-end texture for that tree. And then the Cloud Transfer will go off and make that for me, and it'll cache it. So the next Android device comes online, it doesn't have to do it again. It can just send the version that I made. When your PC comes online, it's like, hey, I've got all the resources in the world. Give me the high quality version. Give me the uncompressed version. I just want highest fidelity. And then it goes ahead and caches that, which means that this is infinitely future-proof also.
And also infinitely instantaneous. So I love Grand Theft Auto, and they have like this new version that's going to be absolutely mind-boggling, which I'm really excited about. If I was an artist who wanted to adjust an asset in hopefully our future system, I would re-upload in about 5 seconds. Your and my game would trigger a new transcoding of that. And literally, at peak concurrency, like something like Grow a Garden with 25 million people, you could in 5 to 10 seconds have all of those new people possibly getting that new asset. This is why I think it's somewhat of the future, because I think part of the beauty of Grand Theft Auto is they bake in so much quality. They're going to put it on a giant DVD. They have to make sure that's perfect, and there is no way to iterate on that. You got to get it absolutely perfect right there. And so then I guess finally on the future proofing, in addition to instantaneous changes, there is something that seems good about storing artistic intent, storing the original work of art in a way. Can you mention how that might help us?
Since we're trying to capture as much original artistic content as possible, and we're storing for this we're storing the source code, the source version of all the assets, and with this as you can imagine, we can not only downsample it by generating simpler versions of a texture, but also upsample it in the future, because we already captured that semantic, that what the original intent was, so we can upscale this asset in the future. So, and without requiring any user input, we can make it look better.
That's going to be a big hint as we get into the future. So let's add a second component to what we've been talking about. So we're streaming, make instantaneous fixes, cloud transcoding, deliver any LOD. And then what we hinted at the start, we're going to complement that with something called Slim. So Slim is not a workout program. It's not like the Roblox snacks that are hopefully going to make us all really feel good and think clearly. What's Slim in the context of the Roblox engine?
You have a tree, and as I said, you might have multiple trees at the distance. Slim is what turns all those individual trees into a forest, and optimize not individual assets anymore, but optimize them as something that's bigger. That's aggregation of individual assets, and it's the Slim technology. It's always optimized those assets in a specific context. So let's say you have a building, right? So and a bunch of rooms inside that building. If you're outside the building, you don't care about the rooms inside the building. So, and Slim is aware about this context, and it can very efficiently remove all the building internals, in that case, and generate a very optimal version of that asset for you.
So there's 3 use cases that as you've been designing this, I've been thinking about. So one use case is people are building more and more complex avatars, and historically on Roblox, we've been very careful. How many layers of clothing can you wear? How much jewelry can I wear? How much stuff? But the future, maybe avatars have many, many things, 100. And I think our creators are very savvy around performance. They may actually constrain the fidelity of avatars because they want so much perf. So avatars that are complex, number one. Number two, as you mentioned, there may be 100 trees over there, and they're way off in the distance, and no one's interacting with them. And then the third is maybe a building with rooms inside. I think what we're going to try to do here is, no matter what it is, a moving avatar, a bunch of trees, or a building, this exact same system is essentially going to composite down into a single object, single mesh, single texture. And that's absolutely mind-boggling.
Yes, you're exactly right. So that's a good word, like, for this. Like, that system is dynamically generate like a composite representation, like, of multiple assets, like, and it determines, like, the boundaries of this composition, the level of details, like, for that composition, like, dynamically. It's always operating, like, in this, like, world context. So exactly the same assets, like, in two different experiences, like, might be optimized differently, based, like, on the target device, based, like, on the context, like, in which they're used, like, and we also support dynamic updates, like, for that content. So it's not always like, it's not like a static optimization. If something is changing, like, over time, this will be reflected, like, in the slim representation, because, like, we can update it, like, dynamically.
It almost, one of the reasons I really like this is it almost feels if I was a Roblox developer and I really wanted massive scale and, for example, really complex avatars, I might be dreaming of this. Like I can walk up to someone close to me, they can take their hat off, they can put on some new jewelry, which is the way this system's going to work. With objects that are close, may work at regular high fidelity. And then as that avatar works away, it composites down into a single object. And as it goes further away with LOD, we joke like the ultimate is an avatar way in the distance, maybe 12 triangles and like a really small texture. So this is almost like what a developer, I think, has dreamed about. And then I think this makes, one of the things this makes possible is larger worlds across devices.
Absolutely. I mean, what Slim is essentially doing is it's giving us a new axis of scalability. So we talked so much about cloud transcoding and different levels of detail. Now we're adding another level of another axis here, which is about composition. Right? And you can think about a 2x2 here, and any point on that is a valid experience. So you could be like high quality, low compositing. You could be high quality, high compositing if you're on a very low end device or a different device. And all of those points make sense. So if you're talking about a massive world, that entire world could be 12 triangles also if you're far enough away, or if it doesn't make a difference.
And so then thinking about user experience and how Slim can lead into a better user experience. If we think about LOD, we think about cloud transcoding. If we think about Slim, we think about streaming. Relative to Roblox today or a year ago, how can this affect the user experience?
Yeah, so Slim, we built Slim with the idea that we are enabling the developers to create richer and bigger complex worlds that are going to behave and interact with the end user very easily, like without, and the end user experience is exactly the same as if you have the most powerful machine. And Slim is this system that today enables static models, and we are enabling in the future avatars and dynamic models that are generated hierarchically so that we can make the system as fast as possible for the end user.
Which for the end user may be more rich worlds on lower end devices. It might be on my low end phone. I can play with you on your gaming PC. Creators can make higher, not worry about the number of layers of clothing on an avatar, more complex vehicles, complicated mechanical objects as well are going to get compressed by Slim, which is going to be really, really cool. And then maybe thinking through how they work together. So we talked about cloud transcoding. So offering lower LOD, then we talked about Slim, which is really lightweight models. Do they work together?
Absolutely, right? And that's what I meant by that axis thing. So all of the Slim models go through the exact same cloud transcoding pipeline as well. Because once you composite them, and once Slim is decided based on the context and based on the content, this is what the composite should be. It goes through the same transcoding pipeline and then generates a low quality version, a high quality version, an Android version, an iOS version for everything. So it's very, very much complementary between.
And so that really, for the creator, is almost like a double whammy.
Yeah,
a very complicated avatar, way at a distance, composited into a slim model, then transcoding. That avatar, once again, could be 12 triangles and like a single color.
And what you'd hope to see, or what I would expect to see, is kind of a first order. All of the existing experiences can just start to run on lower and lower end devices.
Yeah.
But the really exciting thing is the second order effects, right? Creators start to realize, like, oh, I can put more stuff into the world. Oh, I can add more to my
you think
avatar.
about it, if I'm building video, it's almost as if the camera is pretty thoroughly designed. You know, I get my 4K camera, and I never worry, like wherever I point the camera, can I take a movie? Like I do. But our creators don't have that camera today. Like if they point the camera in the wrong place, their world might blow up, right? Like too much resolution. Like if they point the camera at a crowd of 10,000 people, it's like, so this is almost like freeing up the immersive 3D camera.
But giving creators freedom. So we can do platform expansion and then genre expansion.
And I do think there is a time, we do not know when. It is some mixture of Moore's law, compute, slim 3D streaming, AI, local tech, upsampling, whatever, where it may be that this camera is no longer a limitation. Where if you wanted 100,000 people in a giant stadium, photorealistic, hanging out with your friends, streaming on a low-end device, with your low latency, like feels good, that will be, I think, when we say the immersive 4D camera is mature. The good news or the bad news is there's a lot of work to do, so it makes our jobs kind of interesting. And I guess in that theme of how fast we're moving towards that ultimate 3- and 4-dimensional camera, Sergey, what's next for Slim, and like what would we optimize after this?
So for Slim, like a few big steps like in front of us. Like so, the very next step is like to make Slim fully dynamic, to support like avatars, moving vehicles, like moving mechanisms, and all that stuff. But the more important step after that, like, is to make Slim hierarchical. As Varun mentioned, you know, like that Slim generates like pretty much the same assets like as like just regular assets. They go through exactly the same like streaming pipeline. We optimize them because like each Slim model has like individual LODs like and stuff. But like, what if we can take it like even further? What if we can combine like multiple Slims like into one, like, you know, like mega Slim, and then again and again, and like in like this like fractal like way.
So this was part of our design question, because when you originally proposed Slim, we were looking at avatars, and we had a separate project thinking about how would you put 100 avatars together, and how are we going to simulate 100,000 people in a stadium? And what was really, there's this fascinating day when I think you said, you know what, we may be able to take Slim avatars and then put 100 of them into a collection of 100 avatars with exactly the same technology. And that's a little bit where we said, mind blown, like that hierarchical nature.
Yes, that's exactly right. And if you take this example to the extreme, right? So you can think about like, okay, so our like virtual camera, you can see the entire planet. So we see the entire planet, and it's like just, you know, like a sphere, like with a texture. When the camera gets closer, you will see like individual continents, like then you will see individual cities, and then you can go all the way down like to the stadium full of people, because like we have all the simulation running on the server, and client doesn't need to know like about like the entire world. It's clearly, you know, like you cannot fit, you know, like this entire planet into a device memory, even if you're on a powerful PC. But our servers like are very powerful, and by generating this like hierarchical representation for Slim, you know, like we can go like from a planet scale all the way down to the like, you know, like room scale, like, or even like micro world.
Well, right. We may go all the way down to the watch that you or I wearing, looking at the little knob on the watch, and even further than that. And so then, as we think about this, then, Satan, how might this change what creators start to do, right? hopefully get rid of the, oh my gosh, I have to worry about the performance of an avatar. Any other changes you think we might see?
This will remove, in my opinion, all the limitations that they have today. They, as you said, they don't have to think about how complex the world they are creating. They just have to think about what they want to present as a game dynamics to their players, nothing else. Everything else is going to be handled by us automatically.
So, and diving into some of that automatic stuff, you know, there in the old traditional Roblox, we did this thing called texture reatlasing. We actually had a template for a texture, and you would have to figure it out. I'm assuming with a slim model, that's completely automatic, like the generation of that texture at lower resolution.
Yes, that will be automatic, as well as determining those building blocks that Sergey explained in the hierarchical dynamic world.
Okay, so now we're really going to blow our minds, and we're going to talk about. It's easy to imagine something being simpler, right? It's almost like if you're an artist, it's very easy to imagine kind of making it more crude and flattening something out. It's a lot harder to imagine something getting a higher resolution. And so I want to poke a little bit into the future of AI. And there's a lot of work right now on AI, like how we're going to generate video games and real-time immersive streaming and world model and all of that. And I feel more and more we're going to find this is not a monolithic thing. This is going to be a stack of 3, 4, 5, or 6 models all working together, including, you know, a command line where if we're hanging out, like we do with 4D, we can just say, you know, turn the Washington Monument into Godzilla, and boom, it's going to happen right there. And ultimately generate objects or worlds or full games, and hopefully in a multiplayer context. So we're walking around together, the 4 of us, and we're saying, hey, over there, the 4 of us would like to design a new game and have it all magically appear. There's a secondary aspect in addition to command prompt and world gen and 3D, which is what you were saying is upsampling. And that, if I imagine sometimes classic Crossroads, which is a 20-year-old game on Roblox, there's actually enough information there. If we took classic Crossroads and Sergey, you said, make this look like a photorealistic medieval version where the gameplay could be the same, all of those fun little rocket launcher tools are the same, but all of a sudden everything has a new look. So how would this work in the context? I don't know who wants to jump in on LOD, because now LOD has to go up rather than down.
I think one of the points that Sergey made before, right? It's about storing as much of the original artistic intent as possible so that we can do some of this stuff in the future. And my favorite example, and this is a random example here, but imagine I'm using a texture, but that texture was actually a picture that someone took. If I actually stored the aperture size, if I stored the f-stop when that picture was taken, now my upraising algorithm has so much more context. If I know where that texture is being used, if I know that that's being used on a castle, is that being used on the floor, my upraising algorithm can be so much smarter about making that and keeping that original creator intent all the way through on that high-end PC or some future PC that's never been invented yet.
So we showed this at RDC. Like I think we showed like a 15-second video of Crossroads being upsampled. Let's talk about what might actually happen. The asset is in the cloud, the 3D objects, the textures. There's an additional prompt sent into our content system that says, look, all of these assets are part of what should be a much more photorealistic medieval world. One can imagine then all of those different LODs being regened to be much more close to the photorealistic version by what we would call it a 3D upsampler, or really a 3D generative creator. So who wants to dive in on what might happen to the castle, for example?
I think like what Varun just mentioned, since like we're capturing like so much more like semantic like from that world, like that's like what extremely important. Like, so for example, for this like Crossroad example, right? So if you look at the castle, from a perspective of individual assets, it's just like, like a number of blocks. Like you cannot make like those blocks look any better. And the castle is just, it's more than just like individual blocks, it's a sum of them. And Slim, since like Slim operates like in this like context, Slim is aware about this thing like as a whole. So and now like any upsampling algorithm like will know like way more like about like a castle as a whole, not about like individual assets. So it can make like a way more better version like of that upsampled castle because like it just understands that. Like.
And in a sense, one can imagine without having that existing Crossroads castle. And just so everyone knows, Crossroads is a very old, blocky-looking Roblox game. That castle is actually a really good aid to the prompt. Build me a castle over there is a pretty open-ended prompt. Like we're going to get a random castle of a random shape. But the castle in Crossroads actually dimension, size, like that's a lot of good prompt information to upsample into really a high quality castle.
Yes, that's exactly right. So because like this like 3D dimensional part of the castle, first of all, it's going to be like very important like from a gameplay perspective, right? So you cannot just generate like any castle like and make it work like for the game, But if you can capture like all the like dimensions, like all the like semantics, like in all the context, like in what that asset been used, then you can upsample it like very efficiently, and you won't break like your game like by doing this, like because like that's like another very important thing. You don't want to upsample an asset like and make your game like unplayable.
Well, I think there's a future world where, in addition to all your 3D information, you can either be editing your 3D information or editing your prompt. They both come together to generate that world. So the 5-second update we talked about, which is an asset modification, in the future, it may be a 5-second prompt update and a little more hint in the prompt and then lazily generate that world on demand. And then I think there's one last, when we think about all the dimensions of how AI can come together to bring these things photorealistic, there's a final layer, which is the 2D layer, what's happening on your gaming PC, what would be happening in some video appliance in the cloud, where even higher upsampling may occur. So, for example, perfect hair on my head, the best place to do that hair may be locally with a 2D upsampler. I know you've worked on a lot of games that try to do hair in 3D. Do you think someday all hair will be done with 2D upsampling, or will it be 3D hair?
Yeah, absolutely. I think like we're moving like into that direction because like some things like you can only do like in screen space. Like it's more efficient. Like, let me put it like this: it's more efficient like to do in a screen space. Like for example, like this hair like rendering, right? So a lot of game engines like today doing like ML based like upsampling, like going like from like 1080p like to 4K, but you can do like way more than that, right? So you can change the shading, you can change how the things look, and if you take this example like to extreme. Like a game engine can just render, like some like semantic information like for like ML algorithm, like, and then this ML algorithm like will generate, like good looking hairs, like or good looking materials like in screen space directly.
Super good. So then as we start to wrap up, maybe for all of the C++ coders out there, the assembly language coders, which I wish I was like, that's one of the most fun things in the world. We're doing something very difficult here, right? We're trying to make all of these technologies run on all devices. Question on transcoding. And the question on transcoding is, I know a lot of PCs have optimizations with SIMD registers and things like that to make these things run faster. Have we started to probe around with SIMD in any of our transcoders? Or is that future optimization?
So first of all, by the way, transcoding can run on engine as well today.
Okay, excellent.
Assets.
Good.
So we are taking advantage of SIMD optimizations, but we are looking even further than that using GPUs and other.
So
yes.
Transcoding on GPUs is coming, possibly.
Well, yes, we are looking into it.
Okay, which is super, super fun. Okay, so great update, everyone. For those who want visual, possibly RDC main stage presentation. I think we had visuals of a lot of this. Everything we've talked about is on the pipeline. We're watching it carefully, and I really do think all of you and the various teams behind you are really contributing to what would be what I sometimes call game engine 2.0, which is heavily cloud, heavily supported by transcoders and all of this technology. So thank you all. I think we blew everyone's mind today. Really appreciate it.
Thank you.
Okay, so hey, this is Dave. Once again, Tech Talks, and we'll look forward to seeing you our next time around. Thank you for the whole team. Thank you.
We have got to the point where literally anybody can build a fully working app without knowing how to code. This is Base 44. This is a first look at the current industry-leading AI app builder, and you wouldn't believe the kind of apps that people are creating. Smart nutrition apps, inventory trackers, onboarding tools, you name it. And if the only thing stopping me from making the app is the idea, then why not build an app that gives me endless app ideas? So let's make it. Pro tip, I draft the full app spec in ChatGPT, and then I drop the prompt directly into Base 44. It gives me super detailed structure. And here it is. Everything I laid out in detail as it goes. This is pretty awesome, but I want to make it playful. So I'm going to add a swipe left and swipe right interface. The same usability we all know. Now I'm going to add one more feature. So every idea that I favorite will turn into a kickoff prompt to start building the app itself.
Okay, so this girl right here is a criminal, and it's because she literally breaks the law. And guys, did you all